Ever since the heavens first struck with a flash of light, all we've been doing is trying to harness that power. And the outcome of this obsession? Batteries. First created in 1799 by the Italian physicist Alessandro Volta, the battery was the marvel of the century. I even had one myself. It was later improved upon by Dr. John Goodenough. Dr. John Goodenough invented what we now call the lithium-ion battery. Can you believe that?
Volta's brainchild came into fruition after Louis Galvani suggested an idea. Galvani believed that all animals had some sort of special electricity flowing through them. He demonstrated this by connecting two different metals to the legs of a frog.
Volta realized that it was a liquid in the frog's legs, which was more important rather than the frog itself. He replaced it with a paper soaked in brine and got the same effect. Based on that understanding, he put together zinc and copper plates separated with cardboard soaked in brine, which gave us the first primary battery.
What we now refer to as lithium-ion batteries are generally known as secondary batteries. What makes these special is the fact that they're not the one and done type. What I mean by that is that once they're fully discharged, you can recharge them, meaning you don't have to buy batteries every time your remote control stops working or your flashlight doesn't turn on. Such an invention comes with infinite possibilities and benefits, from reduction of environmental pollution to saving you time that we would usually spend to go to the store to buy you a box of batteries.
Compared to our traditional batteries, these lithium-ion batteries can last longer, charge faster, and they also have a higher power density, which increases their battery life. This ultimately means there's less space and more power. This makes lithium-ion batteries ideal in our day-to-day use. And there's no doubt in my mind that whatever device you're watching this on operates on lithium-ion batteries.
Some of the advantages of lithium-ion batteries are: lithium-ion batteries have a high energy density ratio, meaning there is a higher energy output for both the volume and weight of the battery. Second, lithium-ion batteries can be left unused for long periods of time. Unlike other batteries, lithium-ion batteries will not discharge as much over that time. Lastly, lithium-ion batteries can be manufactured in all shapes and sizes, thus making them the battery of choice for consumer electronics. Some of the disadvantages of lithium-ion batteries are: if a lithium-ion battery separator is broken, this will result in the battery shorting, which can result in an explosion or fire. Also, lithium-ion batteries do not like extremes in temperatures. This is because if the temperature is high enough, the flammable electrode can ignite and catch on fire. Lastly, lithium-ion batteries can be up to 40% more than other batteries, like the lead-acid battery.
Lithium batteries are one of the great successes of modern electrochemistry. They will soon dominate the electric automotive transportation and renewable energy storage markets. These batteries have an established role in the consumer electronic market with no risk of replacement by any other contender. The potential of these unique power sources make it possible to foresee an even greater expansion of their area of applications to technologies that span from medicine to robotics and space, making lithium batteries the power sources of the future. To further advance in the science and technology of lithium batteries, new avenues must be opened. Changes in the chemical structures are not sufficient. Further improvements in safety, environmental sustainability, and energy content are mandatory. These can only be obtained by totally renewing the lithium battery concept, so far mostly based on insertion chemistry. Although the insertion electrodes are based on sustainable 3D metals, they are produced from ores, and thus their extraction and manipulation require constantly increasing amounts of energy. Batteries now being used in space are the rechargeable kind, usually nickel-cadmium. They are recharged by solar cells that convert the sun's energy to electricity. However, these batteries eventually wear out and no longer can be recharged. In space, batteries must work in both very hot and very cold conditions. They must withstand a lot of radiation from the sun. They must work in a vacuum without leaking or blowing up, and be strong enough to withstand the severe vibrations of a rocket launch. Lithium-ion batteries are able to meet the more demanding technical specifications without being excessively massive. The chemicals inside them that store the energy are different from nickel-cadmium batteries and store the energy in a much smaller space. Lithium-ion batteries are an essential part of powering NASA. They're on the Curiosity rover, the OSIRIS-REx craft that just launched itself into an asteroid, the Juno-Jupiter mission, and the space station, as well as other current and future ventures. These batteries make good aerospace solutions because they pack wallops of energy relative to their size, hold a high amount of charge over their lifetime, and don't lose that charge quickly when left alone. That's exactly what you want in a space battery, which has to live long and prosper in the vast empty off Earth. Lithium-ion batteries are fast becoming the most common energy storage solutions for NASA missions.